All right, welcome to Building on Bedrock, Elixir's Fundamental Design Advantage. How many of you here have heard the story of the Princess and the Pea? Okay, that's almost everybody, but I'm gonna give you the Cliff Notes anyways. So a princess arrives at a castle claiming to be royalty. She wants to marry the prince, but the queen has some doubts. To test if she's a real princess, the queen secretly places a single pea under 20 feather mattresses and 20 feather beds where the princess will sleep. In the morning, the princess complains that she couldn't sleep because something hard kept her awake all night, and the prince marries her, convinced that only a true princess could be sensitive enough to feel something so small through so many layers. So how does this apply to software? Well, software is the princess. In real life, it's programmers who are princesses, but of course, for this analogy, it's software. So our applications feel the effects of bad foundational decisions through 20 feather mattresses and 20 feather beds. So let's take a look at some examples of foundational decisions. We have infrastructure, the hardware and OS that we are running. We have the build process that we use to actually produce the code that runs on that hardware. We have the runtime that runs on the hardware that we are using, that we built with our build process. We have the programming language that we use to create the thing that we built that runs in the runtime of the hardware that we're running. We have our dev tooling that helps us write that code. We have frameworks and libraries that help us structure that code and provide features and tools. We have the architecture, how we shaped the code that uses the framework. We have even the community, the people surrounding the tech that we chose to use. And that's actually more important than most people realize, or maybe we all realize it, that if you can't get help with the thing that you're doing, if you can't find a forum where people are talking about what you're using, then you know you're going to be out of luck. So I'm here to tell you about Elixir. Show of hands, who's heard of it? Nice. That question gets better answers every time. I think that was almost everybody. Okay. Often when we talk about Elixir, we talk about a lot of different things that it's built on top of. So show of hands if you've heard of Erlang. Less, okay, but not a lot less. How about OTP? Okay, less. How about the Beam VM? All right, okay. So a lot of talks about Elixir do a deep dive on the history of the language, its roots and how we came to be here. And I like to think of this as our heritage as Elixir developers. I do think, however, that this can be a bit overwhelming to newcomers. So today we're going to avoid the history lesson. It is worth knowing, however, that the foundations of Elixir have been battle tested since the 80s, and it's only gotten better since then. Okay, we're going to talk about foundational properties of Elixir that lead to significant positive effects in the software that we produce. First, you should understand that I'm not asking anybody to pioneer anything. This isn't like a new kid on the block and I'm like, please use this programming language. This is used by companies around the world like Discord, Toyota, Square Enix, Remote.com, PepsiCo, BBC. I think you've probably all heard of almost all of these companies. Before I dive into the actual technical stuff here, I'll tell you a little bit about myself. I want to thank my employer, Alembic, for funding my work on Ash and Igniter and my attendance at conferences. Alembic is an international software agency with a deep expertise in web development, distributed systems, and wrangling complex software requirements. We combine great people with leading tech to help businesses build ambitious software applications simply, efficiently, and sustainably. So if you're looking for help, come find me afterwards and let's see what we can do for you. As for who I am and what I do with my day-to-day life, I maintain a framework called Ash Framework. Our tagline is model your domain and derive the rest. It's a batteries included, essentially Lego style building block framework for building Elixir applications. We have a huge ecosystem. I'm personally responsible for millions of lines of Elixir code that are both open source and proprietary. So I do have a little bit of a right to speak here on the topic, but pretty much nothing else. You can ignore my political views, I promise. I also have a book. People are really enjoying it. It's been the #1 bestseller on Pragmatic Programmers pretty much every week since the beta released in January, which is like really mind-blowing. It was very unexpected. So we typically have a little promo code for you. I don't have one now, but if you just hit me up on Twitter or something, I'll find you one, or Blue Sky. So the interesting thing here is I'm going to be talking about Elixir. And the tagline is scalable and maintainable applications. And all that high-level stuff I just told you about, Ash Framework, all that stuff that I do in my day-to-day, we're barely going to mention it here. And one of the things that's really interesting is we talk a lot about the big frameworks we used. Are you using Rails? Are you using Next.js? Are you using I don't know, are using Laravel or whatever, right? But that's not what this talk is about. This talk is about the lower level stuff that these things are built on. And those can make a huge difference. Okay, so the BBC, they use Elixir. Not for everything, it's a massive company, but they have 600 million unique monthly page views. It's a lot. They reach 81% of those that are over age 16 in the UK. They're the #2 largest English language news site in the whole world. And every page view goes through an Elixir application. So, used by big players. Now, we're going to talk about a couple main things. We're going to talk about immutability, the concurrency model, dev tooling, and macros. This is, I might be unique in that I put this up on the big slide of what I should tell everybody about. We'll talk about that in a little bit. So these are not all of the good things about Elixir, but these are, in my opinion, some of the foundational things that make it a good choice. Okay, let's talk about immutability. I'm using JavaScript here because this is the lowest common denominator language that we all sort of probably know some of. So I have a question for you. What is array after this second line of code? So we have array, it's 1, 2, 3. After we say array.concat 4, 5, what is array? Who knows? Anybody? Well, okay, but what is the value, what's in the list? 1, 2, 3? Okay, so yes, that is correct. It is 1, 2, 3. Okay, what about this one? What is array after this call? Is it 3, 2, 1? Raise your hand if you think it's 3, 2, 1. Yeah, okay. So this one back here doesn't change the array. They both are like, prototype methods on the same class, but this one does. So you just have to memorize the standard library of JavaScript to know what happens when you call what functions. They're not colored functions where they like tell you, does this mutate? There's no annotation. It's not like async sync functions where you have any idea. You just have to memorize it. Okay, let's talk about Elixir. This cannot change anything. List will always have the value of 1, 2, 3. And this is a property of the language. It is literally impossible to ever change the value of the list variable, no matter what you do. So if you're familiar with what this means for programming languages, you might ask about what about copying data, right? So if you don't have mutable references, right? If you have immutable values in your programming language, doesn't that mean you're copying things all over the place, left and right? If I want to reverse a list, don't I have to make a new list that has all of the same elements in the other list, but reversed? But people are smart, programmers especially. Not you guys, but the ones who made this programming language. Let's take a look at this example. We have a map here. This is a map in Elixir, a hash map, or a dictionary, whatever you want to call it. It's got one key called numbers, and it's 100,000 numbers, from 1 to 100,000, right? So we can ask the underlying system, just ignore this incantation, you don't ever have to use it, but we can ask it, well, how much memory does this term take up, right? And that right there is 200,006 words. Okay, so now what we're going to do is we're going to add another key called more numbers that's just a copy, right, of the original numbers key. So now we have 2 keys in the map with 100,000 numbers in them. So the question is, what is the size of data 2? If I ask how many words in memory does this take up, what is the size? Do you have any guesses out there? 300. 300. Okay, 300,000? Yeah, okay, anybody else? 200,000. 200,006? Okay, you're very close. 12. Close also. It's 200,008. So all we had to do is allocate new memory for this new key. That's the only thing. So this is called structural sharing. And essentially what this means is that because the underlying system knows that you cannot mutate data, all references to data are safe to share and manipulate. You are, as a programmer, only ever dealing with values. So if you use the same list in another place, well, we just point to that same other list. It will never change. It's always safe to do this, right? So in a lot of ways, we think about writing algorithms over immutable data structures. The sort of, common knowledge is that it's hard to write those efficiently. But on the contrary, you can actually write many algorithms more efficiently without ever thinking about it, because the compiler can just shuffle stuff around for you. It just knows for a fact that all references are safe to manipulate. Okay. So as I said, you only need to think about values. You never think about, is this a reference to a value? Under the hood, it is all references, of course, like everything is still stored somewhere in memory. You get to do this process of structural sharing. Memory is efficiently managed on your behalf. And what this means is that we have a thing called local reasoning. When we have immutability, we have something called local reasoning. You can look at some little piece of code, you can call a million functions and it doesn't matter, and it's not gonna screw with any of the stuff that you just made. Now, if you're familiar working with mutable programming languages, it just doesn't work that way. If you've got a new instantiated object in Ruby and you pass it to some function, you just gotta ask yourself, did that just mess with my object? Is my object the same? So it means less bugs, it means easier code review. So if you're looking at a snippet of code in Elixir, you know that it's not mutating some other piece of code. You can just review that one particular change. It's a really, really useful property. You get fearless refactoring. So you know that you can just shuffle the contents of one given function around, and you don't have to worry about, well, did I stop changing the parent object? Like the object that was passed into this function, I'm not changing it the way I used to be. Was the caller expecting that change to happen? None of that sort of problem exists when you have local reasoning. And ultimately, it leads to happy developers. An interesting new sort of property that's arising from this is that you actually get better AI assistance. So in general, there's a common thought that AI tools, LLMs, are worse at niche languages. We've actually found that not to be the case with Elixir. You need a couple rules just to tell it some basic stuff, but generally speaking, the LLM doesn't hold your entire code base in its context window at any given time, right? So local reasoning, not being able to like accidentally screw up some far distant part of your code base, actually allows for LLMs to be more effective at helping you with your code base. So immutability means simplicity. So in practice, we have companies like Discord who have 5 engineers at the time of whenever I found this case study. They obviously have more than 5 engineers, but 5 engineers for this particular thing running 20 plus services and 400 machines with only 5 people. We have remote.com on the entire opposite end of the spectrum with 200 engineers running a massive global application on 5 pods with 10 gigabytes of memory. So remote.com, if you're not familiar, they're very different from Discord, right? So remote.com has tons of business logic. Like they have to they employ people all over the world. They act as this employer of record. So their job is to know all of the contract rules and legal rules in all of these countries, and they have to bake all of that into an application. So they have all of these engineers, but they get to benefit from that simplicity. And this is a quote from somebody at Remote. I feel confident making significant changes in the code base. Has anybody here worked with 200 engineers on a project before? Raise your hand if you have. Did anybody in that situation feel confident making significant changes in the code base? Yeah, it's just not a thing. Okay, we're gonna switch tacks. We're gonna talk about the concurrency model. Okay, so don't worry too much about this actual code. But we've got this logic to withdraw some amount of money from a bank account, right? So you can see that we've got this function that uses this global balance variable, and it says if the balance is more than the amount you want to withdraw, let's subtract that amount from the balance. Then we create 2 threads, and we have both of them withdraw $60 from the account. And so my question for you is what's the balance of the account going to be after this? Kind of depends on a lot of factors, like on the runtime, like what kind of version of Python you're using, is there locking, like just how fast is your computer? How fast your computer is may change the result of this. You could end up with negative $20 in that balance variable. Okay, we're gonna look at a different version of this. In Ruby, when they have everything is a self, or self in Ruby is an object, right? So you can see this example where if you say self.objectID, if you create two new objects and you ask them to bark in this example, they're going to say, hey, this is my object ID. Now, there's a different form of concurrency model, right? This is not a concurrency model. This is a way of encapsulating state. But Elixir comes with a concurrency model that actually encapsulate, like in the same way that Ruby encapsulates everything as an object, in Elixir, everything is a process, which is a unit of concurrency. So what I can do is I have this dog that's running on a loop, right? Which is going to wait to receive a message to bark. And as soon as it does, it's going to say woof. And then it's going to loop. And this is a basic process in Elixir. It's actually a basic process in most things that do processes. It's just something on a loop waiting to receive messages and do work. So we can, just how we made objects in Ruby, we can spawn a process that is running this loop. And we can tell them to bark, and they'll tell us, when they say self, it's a PID, it's a process ID. So this is the core structure of an Elixir program, is a fleet of processes. They are concurrent by nature. It's internally concurrent. And we have some nice ways to model this stuff that doesn't involve like sort of more esoteric keywords like spawn, which is we can define something called a server. So we say use gen server. This is a little mini server inside of our application, right? That's running concurrently with the rest of the system. And we can say you can be sent a message called bark. And when it barks, it's going to put some text out to the console, and then it's going to say, I have no reply to that. I'm not sending anything back to the caller. And then we can start one of those, and we can say, OK, send it the bark message, right? This is like microservice architecture without having to make HTTP your primary method of communication across your applications, right? So I can run a simple concurrent unit of code. But we want to talk about the process or the properties of this. So we have these things that are called lightweight. These are lightweight processes that we call actors. So we might have 3 of these. The base memory consumption of one of these is 4 kilobytes. It's not uncommon to run millions of these in an application that own, all these little different things, file handles, web request processes, every little thing that you do. They have isolated memory. So each process has its own, these are sort of like green threads, right? Their process is not touchable by the outside world, can't even be read by the outside world. They communicate via message passing. So in this example, process 1 might say, hey, start an import to process 3. Process 3 might send a message to process 2. It says, hey, we're going to import this number 1 object, and here's the stuff. And then it might tell process 1, OK, we imported the thing. And this is actually how these processes communicate. There's typically some structure to this sort of thing, but the underlying system is just processes sending messages. We can link processes together. So let's say process 2 and process 3 depend on each other. They talk to each other. If any one of them, if something happens to the other one, then like this, it blows up. Uh-oh, process 3 blows up. Well, process 2 can blow up too. Process 3 says, hey, I'm down, you're going down too. And you can model these dependencies in that way. We have things called supervisors, which sit on top of a group of processes like this. And if something goes wrong with one of these processes, it blows up. It can send a message to its supervisor, say, hey, I'm going down. And these are not affected. These other elements are not affected, right? So Elixir programs effectively never crash as a unit. Maybe a process crashes, maybe one little element of it crashes. But we have these handy dandy supervisors that start it back up. Say, hey, we gotta keep going, figure it out. Now, what's actually really interesting about this is we have this thing called a preemptive scheduler that makes this actually work. This idea of having a bunch of different processes that are potentially interacting with the CPU, potentially interacting with memory. So let's imagine you have 2 CPUs and 2 processes online. And each one of them asks the CPU to do some chunky piece of work, right? Well, what happens if this other process, process 3 here, wants to do something with the CPUs? Well, they're busy. They're not interruptible. Like a CPU itself doesn't give a way for you to say like, hey, stop doing that other thing over there, come do my thing. Well, the trick here is to have something called a scheduler. And so this is built into the language, built into the underlying VM. And the way schedulers work is the scheduler itself is kind of delegating work to the CPU. And it gives each process that wants to do work some period of time to actually do that, right? So it's like, hey, okay, you're going to get, it's a thing called reductions, don't worry about it, but you're going to get like a few seconds to use the CPU. And if there's something else waiting, that the schedulers can stop like one of these processes and say, okay, process 3, you go do your thing. And then when it's done, process 2 can go back and keep working. And now all of the stuff we've talked about is actually quintessential to that process working. The fact that the data, that the memory these processes have is isolated. The fact that they are immutable, is relevant here because it means that any one of these processes can be stopped safely at any time, and it can pick it back up when it wants to go, right? This allows for a level of concurrency that does not exist in any other system that I know of, right? Where you can have fully saturated traffic and still get some other web request, and it'll get a chance to finish, right? So this allows for extremely efficient applications, right? You can run entire infrastructures on very small machines because everything gets to move forward just a little bit, and that solves a whole host of concurrency issues. So scalability is what we get out of this. You get cheaper infrastructure. This is a really common thing. I think I have some examples in this slide. And resilience, when I talked about crashing, equals more time with your family and better sleep. Now this is a real thing. When I first used Elixir, I implemented it at a company where we had this data importer written in Python. It crashed at 5 p.m. on Friday, like every week. I'm not kidding. It was just a really horrible experience. We rewrote it in Elixir using the primitives that I showed you, using processes, using servers, and it never crashed, not a single time. Sometimes parts of the system would experience degraded performance, but it was usually never bad enough that I had to care on a Friday. I just woke up and fix it on Monday morning because it's all still going. So the concurrency model means scalability and reliability. We can talk about this in practice. Veeps, they used to have 20 Rails nodes, and they scaled that down to 2 Elixir nodes. The same specs on the machines. That is 10, not 10x, 10 divide by 10, whatever that word is that's escaping me right now. But they experienced an 86x capacity increase on 1/10 of the infrastructure. This is a real life practice. This is like a multimedia streaming company, right? So that level of throughput translates to like millions of dollars in infrastructure spend over not a very long period of time. There's a flight simulator called X-Plane, and they wanted to have this experiment where they had 10,000 users. It's a multiplayer flight simulator. 10,000 users in a single session, one multiplayer session. And they accidentally configured a number on the simulator wrong, such that it was sending 1,000x the traffic that it was supposed to. It was supposed to ping like once every 1,000 units of something, and instead it was just every unit was just sending a ping back to the server. And what they found is that accidentally increased their CPU load just to 25%. So they only noticed because they just saw a little, like a hump. Not a spike, not a catastrophic, not a 5-alarm fire, but just a little bit extra CPU usage. And that's how they found out about this problem. I've experienced this myself. When my website makes it to Hacker News, I don't find out because I get paged because it's down. I find out because I see my infrastructure just get a little, like 10,000x traffic. So nobody goes to my website unless it's on Hacker News, gets a little bit higher. We're going to talk about dev tooling. Elixir has really great dev tooling across the board. A good example of this is our testing tool is built directly into the language. There's no like, are you using RSpec or are you using, it's fallen out of my brain what some of the other ones are. We just all use the same one. Documentation, we all use the same documentation generator. We all go to the same website to view documentation for every package. It's standardized, it's the same all across the board. The code formatter is built in. There's no opinions here. It has like 3 configuration options, and the general consensus, if you don't like it, take a hike. We don't want to have conversations on our pull requests about what your code is formatted. Let's all move on with our life. Dependencies. We don't have like requirements.txt. There's not like, we don't have like bun and veet and esbuild and webpack or whatever to like figure out, like, no, it's all just, we have one dependency manager. They all live on one website where we manage our dependencies, and we all use the same interface to actually work with them. So for actually publishing libraries, there's one place where you push them to. There's one way to distribute them. There's one way to build them. For distributing tasks within an application, the same sort of thing. There's one particular tool that everybody uses. They all use the same interface. And this one is interesting. It's not necessarily thought of as dev tooling by a lot of people, but I told you about how Elixir is internally sort of concurrent, right? And what this means is when I build a library, which I do a lot of, I think I have like 55 libraries that I'm responsible for. In Elixir, when you ship a library, it's not just code. It can actually ship like live elements, like it's called an application in Elixir. And when the user's application starts, so does your application start. So that means you can write things like a caching layer that when their app starts, your cache starts. And it has its own memory and all that sort of stuff. So I can actually ship like what you think of as like an end user application with servers and live elements as part of a package. Debugging and observability is built into the language. We have literally a GUI to observe the application that shows you all of the running processes, and all of the resource usage and the memory allocations and what ports and sockets are in use. It's just absolutely insane. It's built into the language. So ultimately, we can leverage this so that each individual like application, library, framework, whatever, leverages all of the same stuff. It's so easy to adopt new tools. It's so easy to try new things. And we have a lot of really cool things worth trying. We have something called Erlang term storage. Erlang term storage is basically like a free SQLite that is available when the language starts. You can store stuff, you can retrieve it, and you don't have to like marshal it, deserialize it, cast it, or anything. It's in the essentially, it's already your language level constructs, and you can just use it. It's free. It's crazy that like just that alone would make me use this programming language, but this is like a given for most programming, for Elixir programmers. We have amazing frameworks like Phoenix Framework. If you're familiar with Rails, it's our version of Rails. Phoenix Framework, I think, is like the most loved or desired framework, according to Stack Overflow survey, for whatever that's worth. We have tools like Livebook. This is like our Jupyter notebooks, but you get to write Elixir in them, and it's really cool. It lets you connect to your running production application as a node because they're like concurrent elements. So we can actually like poke our production from a notebook. We have tools for embedded languages, or for embedded programming, like Nerves and Atom VM. These will actually let you run Elixir and Erlang like natively on a device. We have tools for machine learning and number crunching, NX and Axon. These will let you do things on the GPU. These will let you do like, they call it, NX stands for numerical Elixir. And you can write Elixir code that gets transpiled to GPU operations. We have high-level tools like Absinthe and Oban Pro. So Absinthe is a GraphQL building tool. Oban Pro is like a rescue, sidekick type thing. Also, just that alone is like worth the cost of entry for Elixir. It's so amazing. It uses Postgres. You can transactionally create jobs with changes in your own system, right? So like when a user gets created, transactionally insert a follow-up side effect job. Extremely powerful stuff. So Veeps, I'm gonna read you a quote. Throughout my career, I've never encountered a developer experience as exceptional as this. Whether it's about quantity or complexity, tasks seem to flow effortlessly. The team's morale is soaring, everyone is satisfied, and there's an unmistakable atmosphere of positivity. We are all unequivocally enthusiastic about this language. Awesome. SmartRent, innovation at your doorstep. So these guys do like smart devices in like fleets of apartment buildings. Huge numbers. They're all running on these little Nerves, those embedded languages that I was talking about, right? So Elixir can be used all throughout the stack, web development, embedded programming. So dev tooling leads to faster development, less decision fatigue, this unified ecosystem. Like you don't have to think, well, am I gonna use this one or that one or anything like that? No, we just have really good defaults built into the language. And so dev tooling leads to time to value. How much time do I have left?
You're right at time.
I'm right at time. Well, macros are really cool. All right, I'll just give you some examples here. Not this one. Yeah, there's a lot of companies using Phoenix, for example. Big companies doing big stuff. Whoa. All right, there's my stuff. You can get a link to Alembic here. All right, so there's some QR codes to find out about some of the tools that I told you about. Phoenix, Elixir, and Ash, which is the framework that I built. So thank you all.